Hi there, my name is Solvi Turner, and this is my presentation titled Current Thinking on Technology Leadership in Education. I use the COSIN framework of essential skills to analyze technology leadership within my school, University Laboratory School, which is a K-12 lab school located on the campus of LSU. My goal was not simply to evaluate the technology, but to better understand how tech leadership is practiced within the school, identify strengths and opportunities for growth, and to reflect on what the framework revealed about our current structure. COSIN, the Consortium for School Networking, is a national organization that supports effective technology leadership in K-12 education. The framework organizes technology leadership into 3 domains. The first domain is leadership and vision. This focuses on strategic planning, policies, and organizational direction. The second domain is understanding the educational environment, instructional leadership, professional development, and organizational culture. The third domain, managing technology and support resources. This includes data management, cybersecurity, infrastructure, and operations. Before discussing the results of the analysis, it's important to understand the context of the school. University Laboratory School is a K-12 public school located on LSU's campus and serves approximately 1,400 students. The school is organized into 4 divisions, K2 through 5, middle school, and high school. While we are a public school, families pay tuition to attend. The school also serves a unique role as LSU's laboratory school, which means we are expected to support innovation, educational research, and teacher preparation while providing a high-quality educational experience for students. Total effort in every endeavor is our school's mission. The school strives to maximize student achievement through the development, implementation, and demonstration of exemplary programs and instructional practices. Since we operate under LSU, technology purchases and many tech-related decisions must align with university policies and procedures. Our University Connection provides unique opportunities for collaboration, research, and innovation. As I completed the framework analysis, I found myself thinking about how these opportunities could be leveraged more intentionally to support tech leadership and instructional improvement. The technology leadership structure at my school is small but supports a wide range of responsibilities. Our technology environment includes a wide range of devices that require coordination and support. Rather than a one-to-one program, classrooms share Chromebook carts that are available to any teacher using the space. The school also maintains Mac computers, iPads, and Dell devices, along with dedicated Mac labs and an esports room with 13 Alienware gaming computers. While this variety supports diverse instructional and extracurricular needs, it also increases management and support demands for our small tech team. Technology leadership responsibilities are shared among tech innovation and planning, hardware and technical support, and student information systems and data management, a total of 3 people. Because the team is small, individuals often balance operational responsibilities alongside strategic and instructional initiatives. This became an important consideration throughout the analysis because staffing capacity directly influences our organization's ability to support innovation, professional learning, and instructional technology initiatives. I identified examples of how technology leadership is currently showing up across the school. Under leadership and vision, tech decisions are informed through ongoing communication and collaboration with LSU leadership, governance structures, and strategic planning efforts. School leaders participate in discussions about tech initiatives, STEM programming, and professional learning, and leadership agendas increasingly include topics such as AI, cybersecurity, digital innovation, and their implications for teaching, learning, and school operations. Understanding the educational environment. Based on data collected from teacher observations, teachers are using innovative instructional practices and tech tools to support student learning. STEM opportunities continue to expand across the school. One example is our new Farm to Table initiative. Faculty members have participated in professional learning related to AI and computer science. Managing tech and support resources. The school has established strong practices for device management. Data governance and cybersecurity processes support safe and effective tech use. Systems support state reporting requirements and daily operations, and data is used to inform decision-making across the school. I developed a rating scale to help stay consistent in assessing each skill. The scale ranges from 0, indicating the skill is not present, to 4, indicating transformational. Each skill within the framework was reviewed and scored based on available evidence, current practices, and organizational alignment. Then I combined the scores to create scores for each major domain. The goal was not to create a perfect measurement, but rather to identify patterns, strengths, gaps, and opportunities for growth. The results revealed a clear trend. Managing tech and support resources received the highest score at approximately 66%. Leadership and vision scored approximately 59%. Understanding the educational environment scored 50%, making it the lowest of the 3 domains. While none of the domains reached a transformational level, the results suggest that our strongest practices currently exist in tech operations and support systems. The greatest opportunities for growth involve instructional leadership, communication, professional learning, and organizational capacity. Business management, and data privacy and security emerged as the highest scoring areas. These findings reflect the school's ability to manage complex operational systems, maintain compliance requirements, and support a diverse K-12 environment. One possible explanation for these stronger scores is that many of these areas are supported by procedures, oversight, and guidance provided by LSU and state agencies. Areas such as data management, privacy, security, and compliance often have clearly defined expectations and accountability structures, which might contribute to greater consistency across our school. The analysis also highlighted several organizational assets, including innovative teachers, expanding STEM opportunities, growing awareness of AI, collaborative potential, and our unique partnership with LSU. Beyond the scores themselves, I saw evidence of a culture that is willing to learn and adapt. Teachers have participated in AI-focused professional learning through ISTE, computer science coursework through Southeastern Louisiana University, and ongoing conversations about emerging technologies. These experiences demonstrate a willingness to engage with innovation and build capacity for future growth. The lowest scoring areas included instructional focus and professional development, team building and staffing, and communication systems. One recurring theme was that innovation often occurs in isolated pockets rather than through coordinated systems and structures. Communication tools exist, but communication practices are not always consistent across stakeholders. The technology team also supports a broad range of responsibilities, which limits the capacity available for coaching, professional learning, and instructional support. The framework suggests that future growth will require stronger leadership, expanded professional learning opportunities, improved communication structures, and more intentional collaboration across the school. When I began this project, I expected the results to look slightly different. I assumed that devices, infrastructure, and technical systems would emerge as the greatest needs. I also expected tech leadership challenges to be primarily technical. Because of our connection to LSU, I expected research and innovation partnerships to be more fully developed. I also assumed communication would be a strength because of our school's access to numerous communication tools and platforms. Instead, the operational systems were actually among the strongest areas. The larger opportunities involved communication, professional learning, staffing capacity, and instructional support. Perhaps the biggest surprise was realizing that many of our greatest opportunities for growth are organizational rather than technological. Key takeaways. The COSIN framework revealed several important lessons about technology leadership. Technology leadership is strategic, people-centered, it depends on collaboration and communication, and it requires continuous learning. It also serves as a driver of innovation. The COSIN framework revealed that our greatest opportunities for growth are not technological but organizational. Moving forward, strengthening communication, collaboration, professional learning, and leadership capacity may have a greater impact than any new device, platform, or software purchase. Perhaps the biggest lesson I learned from this process is that effective technology leadership is not primarily about technology. It is about creating the conditions that allow technology to support learning, innovation, and organizational improvement.